we present DOMINO, a dedicated visual framework that guides analysts in investigating events in time series to discover causal relations associated with windows of time delay. The DOMINO interface is made of several visual components. The conditional distribution view visualizing the time-lagged conditional distribution of the target variable given a cause event. The causal inference panel for interactive exploration of the potential causes, including an area chart displaying the cause's influences toward the effect over time, a donut chart showing the effect at the specified time, and a box layout visualizing the cause events ranked by their statistical significance. The time sequence view visualizes the synchronized time sequence values and labels with a time shift for the effect. And the causal flow diagram providing an overview of the inferred relations. We now demonstrate the use of the DOMINO by analyzing the air quality dataset. The full dataset is fetched from a Causal repository, contains 5 years hourly monitoring of Shanghai's PM2.5 pollutant concentration, and weather condition factors like pressure, temperature, humidity, precipitation, wind speed, and wind direction. For simplicity, suppose an analyst is analyzing the data for January 2015 as it is the worst month for Shanghai regarding the air condition. The analyst first loads in data and select PM US post as the target variable, which is the PM2.5 recorded in Shanghai US Embassy monitor station. As he is looking for the reasons increasing the air pollution, the effect type is set as increase. The blue bars now show the distribution of the variable's values across the dataset. The analyst then selects a cause variable, wind direction, and its distribution is shown in the bottom as green bars. As the air pollution usually builds over time, the analysts set a time shift of 6 hours. After clicking the bar of the northwest, the time-lagged conditional distribution is rendered as the green bars overlapping the blue bars. The analyst sees here, conditioning on a northwest wind, the expected value of PM2.5 rises from 86 to 113 after 6 hours delay. So a northwest wind should be considered as a potential cause. Thus the analyst clicks Add, adding it to other panels. A more efficient way to identify potential causes is to use the auto-estimation function. Here the analyst cancels the adjust current causes to estimate causes from all attributes in the dataset. Let's set a time shift of 6 hours, click Estimate Causes. All the estimated causes are shown in the box chart. All the causes are actually very understandable. Dry air, no rain, low air pressure, high temperature, weak wind from the northwest or southwest direction, all contributed in the building up of PM2.5 pollutions. If all the causes are satisfied, after 6 hours, the expected PM2.5 concentration would be almost twice the monthly average. The building process seems to last about 7 to 8 hours before reaching the peak, according to the area chart on the top. One interesting observation is that wind direction is one of the most significant causes of air pollution, while the low wind speed is among the least important contributors. This implies that the external input by wind is a very important factor responsible for Shanghai's air pollution. The analyst can inspect this with more detail in 2 places. First is the matrix showing the intermediate result in causal inference. We see here while wind speed is surely counted as a potential cause, it lost in the pairwise significance test against temperature, leading to its low average significance. Also in the time sequence view, the analyst changes the visualization mode of wind direction and wind speed's timeline to value from the label. Moving the mouse over the time sequence, there is an indicating line showing the value and label of the causes and that of the effect with a time shift ahead. The analyst can now clearly observe that with a strong northeast wind, the PM2.5 is much lower than that with a strong northwest wind. Considering the geolocation of Shanghai, this is also true. The analyst can then finally adjust the epsilon threshold and saves the result to the causal flow diagram. Further exploration can also be made on the chaining effects. The nodes in the chart can be reloaded either as a cause or an effect. DOMINO will automatically decide if it should be reloaded or merged into the current relations.